learned in the last few years that we can use computer vision and machine learning to see or to identify the movements that are related to Parkinson's disease. And there are key movements, so like people move slower, they have tremors. So there are key characteristics of the movement that are very present in Parkinson's disease. So what we learn is that we can use a camera and a video to enhance the clinician observations using computer vision and to make all this automatic so that the clinician can easily just record a patient and the video will be processed automatically and identify if these characteristics are actually present in the video. Parkinson's disease is a neurological disorder that affects movement. So it mostly affects elderly people, like 60 years old plus. And what happens is that they start having difficulty moving, having difficulty doing everyday life activities like dressing themselves, walking. So what we are trying to do is to try to identify factors that allow us to detect the disease earlier than current technologies. We basically, in my lab, we record people doing this same test that the clinicians do. The test is called the Unified Parkinson's Disease Rating Scale, and it's several tests that they perform. We record healthy people in the age where people typically develop Parkinson's disease, and we also record people with Parkinson's disease at different stages of the disease to basically be able to quantify their motor symptoms. So in those videos, you see a person doing one of these tests, most likely finger tapping, which is the one that we use the most. It's very informative. And so basically what happens is that we take the video, just the images from the video, and we pass that to several machine learning algorithms. So the first algorithm basically identifies if there is actually a person in there, because without a subject we cannot proceed. So once that algorithm detects that there's a person and where the person is, we send it to a second layer, which is called post-estimation, which is a way that we use computer vision to track movement. So we transform a full video into just a single piece of data, which is the distance between these 2 points, which we identify using machine learning. Then we can apply signal processing tools to extract information from the data. We can say, do you have a lot of variability in your movement or no? If someone taps and takes the exact same amount of time between taps, there's a very continuous movement, it's very periodic. If someone taps and then stops and then starts tapping again, so there's a lot of variability, which is related to Parkinson's disease as well. So we can quantify all those measurements from the video and be able to track people over time. We wanted to collect a huge amount of data that allows us to really understand how this disease actually progresses, because that is not completely clear because of the lack of data. My dream is that people at home will be able to record themselves, process their data, and then they will be able to contact a clinician and say, hey, I've been doing this test for the last year, and the test shows that my movement is getting worse. And it seems that it goes in the direction of Parkinson's disease. And then clinicians say, okay, I know what you're talking about, come into the clinic and let's do additional tests. So we are trying to make this as accessible as possible because we believe the technology is really useful and we want everyone to have access to it.